Hello students, today we're going to learn about thermodynamic processes. What are these thermodynamic processes? The processes which occur whenever there is a change in thermodynamic state variables like pressure, volume, temperature, number of moles, internal energy, heat energy, etc. is called as a thermodynamic process. Now, there are four thermodynamic processes. One is the isothermal process, two is the adiabatic process, three is the isochoric process, and four is the isobaric process. Let's see one by one what are these processes. Firstly, let's see what is an isothermal process. An isothermal process, as the name suggests, iso means same and thermal is related to heat, which in turn is related to temperature. So in isothermal process, the temperature remains constant. Now if you can see here, we have a cylinder which is fitted with a piston which can be moved up and down easily. Now this cylinder is fitted with conducting walls so that there is free exchange of heat energy from the system to the surrounding and from the surrounding to the system. Now when I push this piston down, the gas is compressed, the volume decreases, the pressure increases, the temperature also increases. In order to keep the temperature constant, there is an exchange of heat energy, or I can say that heat energy is lost from the system to the surrounding in order to keep the temperature constant. Now when I push this piston up, the gas expands, the volume increases, the temperature becomes less. And here again, to keep the temperature constant, heat is gained from the surrounding to the system. Hence, temperature is kept constant. Now, in this process, there is an important condition. That condition is we have to push the piston slowly down and slowly up so that there is a lot of time for the exchange of heat from the system to the surrounding, from the surrounding to the system, and hence temperature is kept constant. So two conditions for isothermal process. One, it should be having conducting walls so that there is a free exchange of heat energy. Two, the piston has to be slowly pushed down and slowly pushed up so there is a lot of time to exchange heat energy. Coming to the second one. Second one is the adiabatic process, which is completely different from the isothermal process. Now in adiabatic process, we do not have the temperature constant, but we have the heat energy constant. That means there is no exchange of heat energy from the system to the surrounding and from the surrounding to the system. Now again we have a cylinder here which is fitted with the piston, but the walls here are not conducting, they are insulating walls. The piston is also an insulated piston. Now this is done so that there is no loss of heat from the system to the surrounding, or there is no gain of heat from the surrounding to the system. And the piston is quickly pushed down and quickly pushed up so that there is no time for exchange of heat energy. Again here, when we push the piston down, there is a change in volume, the gas is compressed, there is a change in pressure, there is a change in temperature because there is no exchange of heat energy. Right? So when I push the piston up also, there is no exchange of heat energy, the volume becomes more, the gas is expanding, the temperature is becoming less, but the heat energy is remaining constant. So the two conditions here for adiabatic process is that the walls of the cylinder has to be insulated, the piston has to be quickly pushed down or quickly pushed up so that there is no time for exchange of heat energy. This is adiabatic process. Coming to the third one, that is the isochoric process. Now when I say isochoric process, again there has to be some variable constant, and here the constant variable is volume. Again we have a cylinder fitted with a piston, but there is no compression or expansion of gases. In order to keep the volume constant, but here the temperature changes, the pressure also changes, the heat energy also changes. There is a heat energy being supplied at the bottom so that there is a change in temperature of the gas molecules, there is a change in the pressure, and there is a change in heat energy of the gas. But the volume remains constant, and this is called as the isochoric process. Coming to the last one, that is the isobaric process. Again, here the variable that we are keeping constant is the pressure. So as the name suggests here, iso is same, baric process. So in the baric process we have the word bar. Bar is a unit of pressure. So in this isobaric process, we again have a cylinder which is fitted with a piston. Heat energy is being supplied from the bottom. There is a change in temperature, there is a change in volume, there is a change in heat energy, but pressure is remaining constant, and that is being monitored by this pressure monitoring device so that the pressure remains constant. So in an isobaric process, pressure remains constant. So students, we learned today 4 thermodynamic processes. One is the isothermal process where temperature is constant. 2. Adiabatic process where the heat energy is kept constant. 3. Isochoric process where the volume is kept constant. And 4. Isobaric process where the pressure is kept constant. I hope thermodynamic process is clear to you all. Thank you.